Alright, if you haven't already, grab out your notes. We're going to look at solving systems of equations using a method called substitution. And so in the warm-up today, we looked at solving systems using a method called graphing, which is great if you have a graphing calculator or a computer program to do. But solving systems by graphing isn't the best way to do it. If you don't have perfect, nice graphs, if the answers are decimals, because it's hard to tell kind of where they're at. So we're going to look at another method called solving systems by substitution. And so we're going to do a couple problems today, maybe 3 together, to kind of give you an idea of what solving systems using substitution looks like. I know it's not ideal not having me there, but we'll still kind of get through it. So if you don't already have your notes out, solving systems using substitution. At the end of this video, I'll just leave this up under the Wojo Algebra Daily Agenda, and so if you want to go back and look at it later, you're more than welcome to do that. Alright, let's look at example 1. So first of all, let's talk about what a system is so we kind of know of it, since this is the beginning of this chapter. So example 1 says solve the system 2x minus 3y equals negative 24. And then to be a system, it can't just be one equation, it's got to be 2 equations. And so the second equation is y equals x plus 10. And so this is a system of equations because it's 2 equations with 2 unknowns. We don't know x and we don't know y. So when it says solve the system, what it's asking us is what's the y and x that make this equation true? And the same y and x value have to make this equation true. So like here, if I said x is 4, 4 plus 10 would be 14. So 4 for x and 14 for y would work in this equation. But if I plugged in 4 here and 14 here, 2 times 4 minus 3 times 14 would not equal negative 24. And so I can find lots of answers that work in one of these equations, but not in both. So we're going to try to find the one x and y combination that works well in both of these. Now this method is called substitution because we are going to replace or substitute this value right here with what we know it is. Since this y value here and this y value here have to be the same thing in the end, we know that these y values are equal to each other. And so systems kind of works like this, or I'll just kind of do one so you can see one, and we'll talk about how I kind of made my decisions. So in solving by substitution, I look for what y or x is equal to. In this case, it says y is equal to x plus 10. So I know that y is x plus 10. So everywhere I see a y, I can replace it with the x plus 10 quantity. So up in this equation right here, I'm just going to kind of make a line and rewrite this equation. It says 2x minus 3y. But instead of saying 3 times y, I'm going to substitute in what y is. It says y is x plus 10. So instead of 3 times y, I'm going to do 3 times x plus 10. And I put the parenthesis there because I'm multiplying the x plus 10, both of those quantities, by this negative 3. And so all of that is equal to negative 24. So real quick, let me just show you again what I did. I rewrote this equation right here, 2x, here, see it's 2x, minus 3y. But instead of writing it as y, I wrote the y as x plus 10 because this equation right here told me y is equal to x plus 10. They're the same thing, so I can substitute them. And so that's what I did. Now the reason I did that is I went from an equation that had an x and a y in it to equations that just have x's in it. This is an equation I know how to solve. And so I'm just going to solve it like I would in our first solving units. I'm going to just rewrite the 2x. I'm going to distribute the 3. So negative 3 times x is negative 3x. A negative 3, don't forget that minus sign out front. That negative 3 times a positive 10 is a negative 30. And that's all equal to negative 24. Now that I have this, I can start to work on solving this. I have x's on the same side, so I'll combine them. 2x minus 3x is negative 1x. Minus 30 equals a negative 24. And again, I'll just keep working on solving this like I always would. I'm going to try to get x farthest away first is the minus 30, so I'll add 30 to both sides. and I get negative 1x is equal to positive 6. So dividing by negative 1, I get x is equal to negative 6. Now when I solve a system, I'm not just looking for the x value, I'm looking for the x and the y value. So what is the x and the y value that make this true? So we're saying the x value that makes this true is negative 6. But now the second step is now I have to find y. So over on the right hand side here, we'll just make a little note. Now we have to find y. We already found x. Now we have to find y. Well, I know from the beginning, right over here, it says y is equal to x plus 10. So if I just rewrite that, y equals x plus 10, I know what x is now. X is negative 6. So again, this method's called substitution because we do a lot of substituting. I now know what x is. X is negative 6. So my y value is equal to my x value, which is negative 6 plus 10. Well, negative 6 plus 10 is the same as 10 minus 6, which is a positive 4. So my y value is 4. And so if we went down and said, all right, well, what's our final answer then? Our solution is the x and the y value that make both of these equations true. And in this case, we write our solution as a point, just like the point of intersection. These two lines would meet at the point negative 6, 4. 4 is equal to negative 6 plus 10, and 2 times negative 6 minus 3 times 4 would equal negative 4. This is the answer that would work in both. Again, this method's called substitution. It works the same pretty much every single time. You have to take an equation that has an x and a y into it and change it into an equation that just has an x and an x into it. The way we do that is we substitute what we know y is, and we take the y out and we put in what it's in its place. So now that you've seen one, let's look at another one and see if it makes more sense the second time. So let me get a clean page here. Give you a second to kind of finish writing if you haven't. And again, you can always go back to this video and watch it again on your own. Feel free. All right, so let's look at a second example. Again, I want to always show a few problems. Even if I was here today, I would show you a few before I'd have you try one. So you're all right if you're not 100% sure what to do yet. All right, so example 2, again, solve the system. So it's going to give me two equations. The first is y equals negative 4x plus 5. And the second equation is 7x minus 2y equals negative 10. Now our goal when we solve this is to find the one x and y that would work in both. If I substituted x, I substituted y, it would work in this equation and would also work in this equation. And so to do that, if we're going to use the method of substitution, we first have to know what either x is equal to or y is equal to. And if I just look at the problem, last time the y equals equation was the second equation. This time it's the first. I know that y is equal to negative 4x plus 5. So anytime I see y, I can replace it with negative 4x plus 5. Well, I see y right here in this second equation. So when I go to rewrite this second equation, I'm going to replace this y. Instead of 2 times y, I'm going to do 2 times this. So it kind of looks like this. When I rewrite it, I'm going to rewrite the second one this time. I'm going to rewrite it as 7x, because I don't know what the x is, so I'm just going to rewrite it, minus 2 multiplied by y. Now, again, I know what y is. The y is equal to this negative 4x plus 5. So I'm going to replace it with the negative 4x plus 5. And then again, the part that you can't forget is you're rewriting this equation. We can't change the equation. We're just rewriting it. So I still need the equal sign and I still need the negative 10. So you can't forget that second part. This equation and this equation are exactly the same thing. The only difference is in this one, the y was substituted, or the y was replaced with what the y was equal to. So once you get to this part, then you're pretty much golden. You just got to get past the first part. Then it just comes back to algebra, just not making any small mistakes. And so in this one, it would be 7x. Again, I'm distributing the negative 2. So negative 2 times negative 4 would be a positive 8x. Negative 2 times a positive 5 would be a negative 10. and that's equal to a negative 10. And so again, I would just keep solving like normal. The x's are the same, are on the same side, so I combine them. So 7x's plus 8x's would be 15x's. Minus 10 equals negative 10. And again, I'm just going to keep working to solve for x. Again, to get x by itself, I'm going to add 10 to both sides to get rid of this negative 10. I know this is stuff that you guys know how to do. And then I get 15x equals negative 10 plus 10, which in this case is 0. To get x by itself, I divide by 15, but it doesn't really matter because anything, 0 divided by anything is still going to be 0. So in this case, my x value that makes this true is equal to 0. But I just want to remind you that we're not done when we find x. When we're trying to solve a system, we have to solve for x and y. So we're not done yet. We found x. Now we have to find y. And so to find our y value, it helps if we already know what y is. In this case, we know y is equal to negative 4x plus 5. I could actually pick the second equation too, it's just more work. But if I pick this first equation, the y equals, and again I picked it because it says y is equal to, and I want to find y, so it's going to tell me exactly what I need. Y is equal to negative 4x plus 5. Well, to figure out y, I just need to know what x is. Good thing we already found it. So I just come up here and I plug in 0 in for x. And that's pretty much what I'm looking at, is I'm trying to find this. At the beginning I could have found it if I would have known what x was. I had to do this work to find x. Now when I go to plug it back in, I get y is equal to negative 4 times my x. Well, my x is 0, so negative 4 times 0 is 0. 0 plus 5 is simply 5. And so my solution then is always, well, we write them mathematically as points, ordered pairs I should say, probably more than anything. Our solution is always written with our x first, so x is 0, and then our y value. So our solution is 0, 5. Alright, this one we could probably go a little bit quicker, but here is one for you to try. The problem is negative 5x plus 5y is equal to negative 15. Negative 5x plus 5y is equal to negative 15. And y is equal to 2x minus 5. I have to keep these videos under 15 minutes. I have about 2 minutes left. So what I really want to say is, alright, if you were going to start this one, I'll get you started, then I'll let you finish it. Your whole thing is, how do I write that first equation? How do I do my substitution? So in this case, this is what y is equal to. So I'm going to just box it in because that's what I'm going to have to replace. Anywhere I see y, I'm going to replace it with this 2x minus 5 because y is equal to y. They're the same thing. So when you write this, you get negative 5x plus 5y. But again, I don't want to write the y. So as I'm rewriting this equation right here, my whole idea is to get rid of the y. So I have x's and x's. And so when I rewrite it, it's negative 5x plus 5 times y. And my y value is 2x minus 5. And so instead of writing this y, I'm going to write the substitution. And I'm just going to keep writing the equation, equals negative 15. At this point, I would just solve it like normal. I would just keep going until I get my x, and then I would plug in my x back into this equation. Once I find it, I'm going to plug back into the y equals equation. And so I'm going to leave this kind of as a you try for you guys. When you're all done and you do this part, you should end up with x equals 2. When you're all done with this part, you should end up with y equals negative 1. And so your final answer would be written as 2, negative 1. So go ahead and try this really quick. If you make some mistakes, help each other out. Go ahead and go back and look at the videos if you'd like. Again, we'll talk more about this on Thursday. And we'll kind of see what you can do. I left you 10 problems to try with some challenge problems with some hints. Good luck to you, and I'll see you on Tuesday.